Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss how we can load JSON data in Snowflake. Okay, so if you recall the fundamental discussion of big data domain, there are three V's basically. One is volume, that is in big data domain we generally work with huge volume of data. Then there is velocity, okay, that is we might have to handle the streaming data also. So how to handle the streaming data in Snowflake, regarding that also I have explained clearly one project related to AWS Kinesis and Snowpipe or external Snowflake table approach. And another very important V is variety, okay, that is in big data world we work with different variety of data. That can be structured data like tabular format data, simple, which is having a schema. Then it can be completely unstructured data, okay, like for example image data or video data where you will not able to find any structure. And there is something which is called semi-structured data, which is coming in the middle of structured data and unstructured data. What it says, basically you will be finding some schema level information from this kind of data, like for example JSON data, Parquet data, Avro data, ORC data. In this kind of case you can map them in semi-structured data, right? Now I am going to discuss with respect to JSON data load, but same kind of concept with little bit modification you can apply in Avro, Parquet, ORC, all different kind of semi-structured data. Okay, right? So before going to the practical section, let us try to understand one important concept in big data domain and frequently asked interview question, that is schema on read versus schema on write. Okay, so if you just think in traditional RDBMS system, what we do, we basically define a schema, okay, that is in the DDL statement. If you consider that first column is int type, second column is string type, okay, what is the length of the varchar data type, all these things we specify. That is nothing but schema of that table, right? So first we create a schema for the data before it is written into the database. Okay, that means when suppose this is our source system and this is our RDBMS, from source if the data is coming in the database, before writing the data in the database we validate whether the data is following the schema what we already defined or which is predefined in this particular table. If they are matching, then we can simply load the data. But if the data being loaded does not follow the same schema, then the data load is rejected. Like for example, in the destination, you have specified the schema, maybe 9 columns are there, okay, and from the source initially 9 columns only transmitted, okay, so 9 column data was reaching here and the data types also was matching with the predefined schema and it is getting ingested simply. But suppose the business requirement change, or maybe in source system now due to some reason they started sending 10 columns, okay, instead of 9. Now due to this addition of 1 column from the source system, when the data will come here, as it is having 10 columns, but in this particular table we basically specified 9 columns, what will happen? Obviously 1 column information will not be able to ingest, okay, kind of loss we can say, right? Or if we want to really take that particular column, what we have to do? We have to do lot of rework. That is, we have to change our ETL flow or ELT flow or whatever pipeline is ingesting the data, and then only we will be able to load this extra column, right? So rework activity is coming in this kind of case, okay, and this is called schema on write. Okay, that is when we are writing the data from source system to our RDBMS system, first we are validating the data against the predefined schema, then only we are writing. So that's why it is called schema on write. While writing the data, we are validating the schema. Okay, not only that, rework is obviously one of the major problem if the schema of the source system evolves or changes over time. There is one more thing, that is to define this particular schema in the destination, the developer or the user should have a clear picture what the business requirement is, right? Until they know the business requirement completely with clear-cut idea, they cannot create in the destination side any schema, okay, right? That is one more problem. But in agile world nowadays, when we are working in project, then ingesting the data and simultaneously work with business team to understand the business requirement goes parallelly. Okay, now in that kind of case, user don't know what are the columns from the source system required. Then obviously if we able to build such system where whatever data with whatever schema coming from the source, without validating the schema, if we can simply load in the destination, that will be very useful. Later in future point of time, what we can do, while reading the data from this destination table, we can impose some schema or some structure. That is not a big deal, right? But at least with respect to source, we can capture the complete information, or if in the source due to some reason with time the schema changes, new columns are added, that complete information also we can able to keep in our destination data warehouse. Okay, it is not like we have to change, then only we will be able to capture the new column data. Okay, so we have to think such architecture in this kind of case where semi-structured data is there, where the schema is not fixed, it might change. In that kind of scenario, to avoid ETL or ELT rework, to avoid having a clear idea before starting the development and making the process delayed, to avoid all those things, it will be very convenient that if we able to build such system where this is our destination and this is our source, then what we can do, instead of following the schema on right approach, what we can do, whatever from source system the data is coming, if the schema changes with time, that also does not matter, put all of them in a particular column. Okay, maybe here you can specify as timestamp when the data is being loaded, and here only one column can be there. Okay, in that column all the data you load. Okay, that is whatever data is having different columns, whatever, that you put in one single column. Then use this particular table in your next ETL or ELT flow. Okay, then you can put whatever columns are required from this particular column of this table. Okay, that is called schema on read. Okay, that is while writing the data, we are not imposing any particular structure or any hard rule. But after writing the data, while reading it again for our requirement, maybe suppose here whatever data is loaded, that is having 5 columns, but for our requirement for the time being only 2 columns are required, we can pull only those 2 columns. Okay, and maybe in source system currently 9 columns are getting transmitted, in the destination also 9 columns data will be stored in one single column. Then suppose tomorrow it is changing the schema in the source, the schema evaluation happens, and now it is transmitting 13 column data. Now here, without any rework activity, here also that 13 column data we should be getting captured. Whether we are using that rest columns information, that does not matter, but at least we will be having that in our enterprise data warehouse. Once we have that, in future if required, we can simply pull that from this particular table, right? That is advantage, right? So that's where this schema on read comes. I hope the concept is clear. So Snowflake invented a new data type called variant, where we can use this kind of schema on read functionality. That is, all the data we can put in a single column, and here you don't check this schema. Whatever schema, let it be, you can simply ingest there. Okay, that is basically it is having flexible schema. This is a proper term. Okay, remember this variant column, very helpful. You can explore documentation for details also. Okay. Now that also means that as the data source evolves or changes over time, this schema changes, new attribute or nesting or array are added inside one particular element, whatever is possible, right? Then no recoding of ETL or ELT is required to adapt that new fields. Okay, that is advantage because it is not checking the schema itself. It is saying, okay, you can put everything. Later, while reading it from that table, from that data warehouse table, you can adjust based on schema. That is what schema on read is. Okay, and the variant data type does not care about the schema varies. You don't check the schema itself. While reading, you can change the schema and do whatever. Okay, now obviously for some advantage, some disadvantage will be there. Let me discuss little bit. So if you consider the comparison, schema on write will give you fast result because here in the source, from the source when the data is coming to destination data warehouse, there before writing the data itself, we are validating it is having the schema matched or not. Okay, that is clean data. It will be always having in the data warehouse, that is in the destination side. Not only that, as the data is completely structured in case of schema on write, then obviously fetching the result will be little bit faster. Okay, but in case of schema on read, whatever coming from search system, we are simply putting in destination one particular column. It will be kind of key value pair it will be having. So to read the data, it will be taking some time. So basically slower result it will be having. Okay, so you can consider like this way. In schema on read, writing is very fast, because while writing we are not validating the schema, we are not checking whether schema is getting matched with the incoming data or not. Okay, that's why in case of schema on read, writing is fast but reading is bit slower. Okay, because we have to process that by some amount to make it usable in our next pipelines. Okay, but in case of schema on write, what happens? In case of schema on write, read is very fast because the table is completely clean, it is structured. But while writing the data, what we are doing, we are validating the schema. That is little bit time consuming. So in case of schema on write, the writing process in the data destination takes time. Okay, then schema on write is not agile and schema on read is very agile. Okay, like I have told you, right? If with time the business requirement changes, if with time we might need to pull new columns, then in case of schema on write, lot of rework activity has to be done. And not only that, in case of schema on write, user need to have a clear idea before starting the development. But in agile world, we do parallelly things, right? So it is very agile. Just load it and then use it. That's it. Nothing else. Okay, and schema on write mostly work with structured data, and schema on read mostly work with key value pair semi-structured data, not unstructured, better to say semi-structured data. Okay, and schema on write is SQL and schema on read is like NoSQL. Like I told you, that is it is following key value pair kind of behavior. Okay, right? So I hope you got some feeling. Now let's see. We already know this particular piece, how to implement schema on write till now, whatever we are doing. Now we'll see how to apply this thing in Snowflake, schema on read. Okay, that is without checking this schema, it should be loading the data in a particular table, and then we can read the data from that table for our future reference. So here I'll be going to the notepad, and here I'll be copying some code. Okay, and then here I'll be going back to Snowflake and I'll be pasting these codes. Okay, so first I will show you. I'll be going to AWS Management Console. Here I am having two S3 buckets. Okay, so here demo testing, this one. Okay, here some JSON data is there, right? I'll be showing you the JSON data also. But before that, first let me create the database, ramu, and then here once it is created, I am using that particular database. And then here, see how I am defining. Create or replace table, JSON testing, JSON column testing variant. Okay, so basically only in this particular JSON testing table, which will be created under ramu database in public schema, it is having one column which is having the data type variant, and the column name is JSON column testing. No other column we are specifying, right? That's what I told you in theory also, that you can use this variant column. Let's see. I will run this particular one, and then here I am creating a file format, okay, which is having JSON, and then here I am creating one external stage pointing to this particular S3 location, demo testing hist inc. If you see, this is the bucket name, and that's what we are using. We are specifying the file format, AWS key ID and secret ID. Generally we should use role based authentication, but this is just a demo. I'll be deleting this AWS key ID and secret ID after this demo, so no problem. So I'll be creating this stage. Now here if I use list stage, what we'll be getting? We'll be getting the data which is stored in the S3 bucket or external stage. Okay, now here what we'll do, we will execute copy into command. But before that, let me show you the JSON data. Okay, so I'll be clicking here and then let me download this. Or let me pause this. Let me check it is all. If it is already downloaded, it is going to take some time. So here, yes, this is the one. Okay, I'll be sharing this data also. So if you see, this is a JSON data. Okay, how it is having ID, there is key value pair, ID, average covered charges, okay, then average total payments and all these things. Okay, and if you see here, this complete thing is one JSON, then here another JSON started, but there is actually no delimiter, but Snowflake will understand this kind of thing. Okay, no problem. So here what I will do, this is the JSON data. You can see it is having completely messy data, and if we have to define this for individual columns, then it will be a very hectic job, but we have specified variant data type. Now if I execute copy into command in our JSON table from external stage, let's see. So if I execute, you will see that data got loaded. Row parsed 30,000, row loaded 30,000, no error seen, and this is our file basically. Okay, we have not specified any schema explicitly for ID or for other things. Okay, only thing is Snowflake automatically loaded everything in variant column. So I hope you are getting the feeling that here schema on write is not applicable. Now if I execute select star from this particular thing, here you will be getting the JSON data like this. Okay, so this is one single column. You see, this is one single column is there, and in this particular one, if I click on one element, it will be having this kind of key value pair. Okay, so see, it is having this key value pair. Okay, so this is what about schema on read. Okay, that is, we are not at least validating the schema against the ingested data. Now what we will do, if I want to read the data from this particular table, then you can apply this particular code, that is extract data from variant data type. Okay, that is, you first specify the column which is variant column. Okay, so what is our variant column? Our variant column is basically JSON column testing. Okay, so here you can specify JSON column testing, then colon, then you can specify the key for which the value part you want to extract. Okay, then JSON column testing colon, another key I have passed from the parent table, which table is having variant column. Okay, now if I execute that, then here we will be getting the data as tabular format. So basically now we are reading that, then we are basically converting this kind of structure and then loading some other table we can do. But suppose you are giving such key which is not even existing, maybe hello world I can specify, then you will be getting null for this hello world column. Okay, so see, hello world column is null because that particular key is not available in our JSON data. That is the one thing. Not only that, here what we are doing, here basically we are specifying the variant column, right? But in our table, if you see select star from JSON testing, the first column is the variant column, right? So you can use $1 also to indicate the first column. No need to give the actual name. So select $1 colon the key, comma $1 colon the total discharge from JSON testing. Not only these two, multiple things you can specify. Like for example, I'll be taking this one also. Suppose I want to take this one. So I'll be clicking on done, then here comma $1 colon this one from JSON testing. So if I execute, it understands automatically that $1 means basically the first column. Okay, so that is one thing. Now coming to the next important concept, which is load with simple transformation. Okay, currently what we did, we basically executed simple copy command to load the data, no transformation. Okay, but suppose you want to do little transformation, then you can do while ingesting the data using copy command. The detailed documentation you can follow in the description box. I'll be providing the link, but here I am just going to show you a simple transformation. That is, we are going to add one extra column which is having current timestamp. Okay, so create or replace table JSON testing, same table I am replacing and keeping the same variant column. Along with that, we are keeping a refresh time with timestamp data type. Okay, I executed that here. Okay, I think due to this it is throwing error. Let me comment it out and then let me run this one. Okay, so table JSON testing successfully created. Now what we can do, we can execute copy command. So copy into JSON testing from, not only this kind of copy command you can use where you can specify directly the stage related things, but here you can use select query also in this stage. Select t.$1, that is first column, which is basically variant column from the external stage, comma current timestamp. Basically I am taking current timestamp also from the external stage for which we have given the alias name as D. Okay, so now if I execute this one, very simple, I hope you are getting. Now it will take some time, and see, data loaded successfully, and here we can execute select start from JSON testing. Here you will see the refresh time is added. That's it. Very simple, right? Not only this, you can use case statement and other transformation as well. You can check the documentation of Snowflake. I will be sharing the link in the description box. Okay. Now here I am going to show you another interesting JSON format. So here if you see JSON data, how it is having, this is one particular JSON object, another JSON object is like this, like that it is going. Okay. Now if suppose one particular new key value pair is coming from source, obviously in that same variant column you can put that, not a problem. But there is another JSON thing is available, which is kind of having one array. Okay, so if you see this particular JSON data, here one outer array is there. Sorry, let me close this. Yeah. So here you see JSON objects are comma separated, but externally it is kind of inside one array. Now how to load this kind of JSON data I am going to discuss. Okay. So here first what I will do, JSON testing with array, skipping same thing, variant column. Okay, I will run this particular one, and then here JSON format also same code, type JSON I am specifying, and then here stage, we are creating a separate stage ext JSON stage array which will point to hive information. So here if you go to S3, earlier we worked with this particular bucket, and this is another bucket where we are creating this stage. Okay, where basically array JSON kind of data is stored, hive information. Okay, so S3 colon hive information, keeping same thing rest of the part, executing that, and then if I execute list, then obviously we will be getting that array JSON.json. Okay, now let's execute copy command, copy into this particular one from the external stage. If I execute, you will see that here one interesting behavior happening. If you check the JSON data, okay, so here if I go and if you check the JSON data, here this is one row, this is another row, this is another row, this should be another row, like that, right? But due to this external array, what is happening that in Snowflake it is showing row loaded 1. That is the whole thing, it is inferring as a single row. See, here inside one array only the complete JSON data is coming. But actually we need to exclude this external array and we need to take individual object inside that array as one row, right? That time what to do? That time first let me truncate this particular table, and then here I will just change the file format. Here in file format we have to write strip outer array equal to true. That time JSON will ignore the outer array and individual object inside that array it will be considering as one row and it will try to load, right? So let's execute this. Okay, and creating the stage again, and then if I execute list, obviously we'll be getting array JSON. Now if I execute copy into command, it will be showing row parsed or row loaded. How many? It should show. If I show you this, so this is 1, 2, 3, 4, 5, 6, 7. 7 elements are there inside array. So 7 rows should be loaded, not one single array. Okay, let's see that. So if I execute copy command, see row loaded 7. Now if I execute select start from JSON testing, not JSON testing, what is the table? JSON testing with array. Sorry. So now if I execute JSON testing with array, you will be seeing, see, 7 rows are there and each row is having basically that element which is inside that array, right? This is another thing. So this is how you can play with JSON kind of data, and hope you are getting the power of variant column. See, we are not defining the schema, that is color is should be having string type, value should be having string type. Suppose in future one more key value is added in the JSON, no problem, load that, it will be coming here also, right? So it will be simply loading that data, no problem, right? So that's how schema evaluation it is handling. And while reading the data, like here I have shown you, right? Select $1 some key, $1 some other key, like that. That time the subpart of the data when you are extracting from this particular table, you can put that extracted data in some structured table, not a problem. But at least in data warehouse, to ingest the data, you no need to do any rework if the data is getting changed, if the schema is getting changed with time, right? So this is all for this video. All the codes I'll be providing in the description box or in the comment section. If you want, you can go through that. And if you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.